Let's program print number 20 in your packet. In this particular program, we're going to create both a pocket boundary and the first time that we have inserted a pocket island. The first thing we want to do is we want to go in and create a new program. I'm going to select Program Manager from the input screen, select New Conversational Program, and that created a new program called No Name Number 2. Let's go back to the input screen and let's set up some stock geometry for this part. Go to the Part Setup screen, More, select Stock Geometry, answer yes that we want to manually size our stock. This is a box, so we're going to simply enter the information on the print. It's 10.25 in the X, it is 7.05 in the Y, and this part is 0.85 thick. Now we notice the center of the large radius is 0, and we have some values here in the bottom left corner for X and Y to move our stock into position. So we're going to put those values in. We have a minus 4.3374, we have a minus 3.5179 for the Y, and that should bring our stock into position, making the center of that large radius our 0. Let's go back to the input screen and let's create a tool for this part. It says that we need a 3/4 inch end mill, so we'll go to Tool Review, Tool Setup. We have no tools described at this point, so we're going to create a new tool. It's an end mill, 0.75 in diameter. The tool cowl length will be set on the machine. We will put a surface footage of 1200, a chip load or feed per flute of 5 thousandths, and we'll use a 2-flute end mill. Let's go back to the input screen and we can begin to write our program. This particular program will be a milling, lines and arcs, and that brings us to segment 0. So let's figure a starting point for this particular feature. We're going to start at the 9 o'clock position of the large radius. The center of the part is 0, 0, the center of that radius. The radius of that first arc is 3.19, so our starting point in X is going to be a minus 3.19. The Y starting point will be the center of the part. It will be 0. We'll put a Z start and a Z bottom. This particular feature is a 1/2 inch deep. We're going to use tool 1, and this will be a pocket boundary. Spiraling inward is fine because we're going to add a pocket island. We want to be able to come towards the island, not starting in the center and moving out. So we want to go inward when using pocket islands. Pocket overlap is 50% of the tool. That's fine. I'm going to put a peck depth of 0.1 and a plunge feed of 20 inches a minute. Now that brings me to my next segment. This is going to be an arc. I want to climb mill the inside of this pocket, so I want to go in a counterclockwise direction. So I'll select counterclockwise. Now this arc swings all the way around and makes contact with a line. So I don't know without triggering out that point what the end point of the arc is. So I'm simply going to leave them blank. Again, in lines and arcs, if there's some information that I don't know, I leave it blank. And do not put 0 because 0 is a value. Let's continue to put the information that we do know. I know that the center of this arc is 0, 0. And once I enter that, you can see that there was enough information for the control to figure what the radius was, so I don't have to enter that information. So we're simply going to go to the next segment. This next segment is going to be a line. I do not know the end point of this line for the same reason I didn't know the end point of the previous arc. this angled line meets with an arc at some point. I could trig that, but the control will do that for me. So I'm going to skip those. In this case, I also do not know the length or the angle of this line. All I know is that this is a line. Again, following the rule, if I don't know it, I leave it blank. I'm simply going to skip all those fields, hit next segment, and move on to the next arc. This arc is also going to be a counterclockwise arc, of which I do not know the endpoint because it meets up with this the next small half-inch arc. So I'm going to leave those blank. I do know the center, 4.06 in X, 0 in Y, and the radius is 1.12, that's the print dimension. So all the information I know about that arc. So we go on to the next segment, which is also an arc. And this little half-inch arc is a clockwise. It now reverses direction on the direction of rotation. So I'm going to leave that at clockwise. Again, I don't know any of the endpoints or the center point in this case. What I do know that it is a half-inch radius. So I'll put that information in. Now you'll notice that none of the blanks that I have been leaving as we move here has been able to be filled in because so far not enough information has been given. But let's do the last segment, which is this final large counterclockwise arc. And in this case, we're going to move right back to the beginning point, the same place we started this contour. So we know all of the information necessary. We know the X end, the Y end, the center. We know the radius, but it did calculate it. And now it's had enough information, you'll notice in that right-hand column for the XY start, was able to calculate all of the information so far that we were unable to provide. And in this case, it also provided or calculated the sweep angle, which is the degrees of angle that that particular arc sweeps. Sometimes the print will have that information, and you can simply put that in and use that as part of the known information. So if I were to go to draw, I'm now going to see that pocket is in fact correct. Now we want to insert the pocket island to be left in the center of that large radius. That island is simply a circle. I'm going to select milling, circle. You see that is block 2. The center is at 0, 0, and the radius in this case is 0.5 to give us a 1-inch diameter circle. Now because this is an island, I don't need to fill in any of the other information. I'm simply going to go down here to the milling type, select Pocket Island, and you'll see that most of the information has disappeared. This is an island left standing in the center of a pocket. The control knows what tool to use, how fast to cut it, how deep to go, because it is in a pocket. The only thing necessary in a pocket island is the X and Y data describing the island shape that the tool cannot interfere with. So simply a circle with this XY data should give me, when I draw now, the pocket leaving that island standing in the center.